Hello students, today we will be covering a very important topic of chapter number 1. It is Gauss law. Gauss law is also called as the Gauss theorem. Gauss law बच्चे हमें किसके बारे में बताएगा? It will tell us about the flux. Flux क्या होता है ये हम ऑलरेडी प्रीवियस क्लास के अंदर कवर कर चुके हैं. So Gauss law हमेशा जो एप्लीकेबल होगा वो 3D क्लोज सरफेस के ऊपर एप्लीकेबल होगा. So Gauss law will be applicable only to the 3-dimensional closed surface. It will not be applicable to 2D surfaces. This can be treated as the limitation of the Gauss law also. 3D closed surface means it should be closed from all the sides, from 3-dimensional. Just like you can treat cube as a closed surface, 3-dimensional closed surface. You can take sphere as a 3-dimensional closed surface. You cannot take sphere as a closed surface because it's 2-dimensional. So in order to apply the Gauss theorem, you have to consider closed surface, and that closed surface must be closed surface. So now coming to the definition of Gauss law. According to Gauss law, the flux linked with a 3-dimensional closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that closed surface. So, in terms of the mathematical formula, we can say flux, it is electric flux associated with closed 3D closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that 3-dimensional closed surface. So, in other words, it can also be written as Q net upon epsilon naught, because 1 into b Q net is Q net. So, this is your basic definition of the Gauss law. That flux linked with a closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that closed surface. From the definition of the flux, we also know that flux is integral of E vector and surface area vector. If I will just put the formula of the flux in the above Gauss law formula, so there comes the second definition of the Gauss law. For example, I am just putting this formula of the flux in the Gauss law basic formula. So what equation I will be getting? So in spite of phi e, I am just writing integral of E vector from ds vector is equal to Q net upon में epsilon naught. I have just put in the value of phi e, that is the flux, in the basic equation associated with the Gauss law. So now, as the Gauss law is applicable to the closed surface, so I am putting a round circle here. This round circle is representing here that the surface is closed. So from this formula, we will be getting one more definition of the Gauss law. That is surface integral of electric field. Surface integral of electric field over a closed surface, that must be 3-dimensional closed surface, is equal to 1 upon epsilon naught times the net charge enclosed by the surface. So both the definitions are derived from the formula itself. If you will just see this formula, it is the flux linked with the closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that closed surface. And if you will be just putting the formula of the flux here, so we will be getting this equation. From this equation, what will be the definition of the Gauss law? It will be surface integral of electric field over a closed surface is equal to 1 upon epsilon naught times the net charge enclosed by that particular surface. So this is all about the statement of the Gauss theorem. So now we will be covering the proof of this Gauss theorem, that how this formula has been derived. So in order to make the derivation of this Gauss law, we are simply considering a point charge, that is positive point charge Q that is lying at the center of a sphere. So this positive q charge is lying at the center of the sphere, and the sphere is having the radius capital R. So we are just considering a very small surface of this sphere, which I am just representing it by ds. ds is approaching to 0. ds इतना छोटा है कि ये किसको अप्रोच कर रहा है, 0 को अप्रोच कर रहा है. I once again repeat, ds is approaching to 0. It's nearby to 0. It's not exactly 0. So this is small area which I have considered anywhere on the sphere. So what will be the area vector? As we all know that the direction of the area will be radially outward. It will be moving outward from the surface. So what will be the direction of the area vector? Area vector will be ds vector. It is at an angle of 90 degree from that particular area. As this charge is positive charge. ये कौन सा चार्ज है बच्चे? Positive charge है. And we already know positive charge की वजह से electric field lines का direction क्या होगा? It must be radially outward. So in this direction, what will be the direction of the electric field? Electric field will also be radially outward. Because from positive charge, electric field lines always move outside. You can also show it by complete line. This is electric field line, right? So we will be just using the definition of the flux. From the definition of the flux, from definition of flux, flux is equal to integral of E vector dot ds vector. So we will be just opening up the dot product. So it will comes E ds cos theta. If you just have a view on the angle, what will be the angle between the electric field vector and area vector? The electric field vector and the area vector both are parallel. It clearly shows that the angle between the electric field vector and the area vector is 0 degree. So the value of the theta will be 0 degree, and we all know cos 0 is 1. So flux is equal to integral of E dot ds, as cos 0 degree is 1. If you will just see by the symmetry, electric field is constant throughout this sphere. क्योंकि बच्चे जो आपके पास positive charge है, that is lying at the center. As the positive charge is lying at the center, so its behavior is very similar at this particular location, 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 because the charge is lying at the center. So distance is symmetrical. हर जगह पे distance कितना है? R है ना? So its behavior will be same. So as a result, because of the symmetry, electric field is constant. So we will just taking out the electric field because of the symmetry. As electric field is not changing with respect to the location, so we are just taking out from the integral. So what will be the integral of the small surface area? Small surface area integral क्या होगा बेटा? Complete surface area, or you can simply make the integral here. Constant का integral क्या होगा बेटा? जिसके रिस्पेक्ट में कर रहे हैं, s के रिस्पेक्ट में कर रहे हैं तो s हो जाएगा आपके पास. So phi e is equal to e into में s, where s is the surface area of the sphere. Make sure कि ये जो आपके पास आपको ये दिख रहा है circle, this is not the circle. This is three-dimensional sphere. Because Gauss law is applicable to the 3D shapes. So आपको देखने में तो बेटा बोर्ड के लिए, बोर्ड पर मेरे लिए पॉसिबल नहीं है स्फीयर बना पाना ना, because sphere is a three-dimensional object. So I'm just representing this as a sphere. So it's a sphere. Right? So what will be the surface area of the sphere? We all know surface area of the sphere is 4 pi r square. So what will be the formula for the flux now? That is E into में 4 pi r square. As it's a point charge, and the distance of this location is r. So we know that from the definition of the electric field, it is the electric field because of a point charge. The formula is k q upon में r square, where k is the electrostatic force constant or Coulomb force constant, q is the source charge, and r is the distance at which we are calculating the electric field. So we will be just putting the value of the electric field in this formula. So what will be the flux? Flux comes to be in place of E, I'm just writing K Q upon में R square, and here comes 4 pi R square. So flux is K, it is the electrostatic force constant. As we all know that the electrostatic force constant in terms of the permittivity is given by 1 upon में 4 pi epsilon naught Q upon में R square, and here comes 4 pi R square. From R square to R square, it will get cancelled out. From 4 pi to 4 pi, it will get cancelled out. We have left with flux is equal to Q upon में epsilon naught, which is your statement of the Gauss law. So this proves your Gauss law. This proves Gauss law. So that is all about the Gauss law and its proof. In the next class, we will be covering derivation of Coulomb's law from the Gauss law. For more videos, just like and subscribe this channel. Goodbye.